This is the first set of solutions. So the short warm-up questions. Now if you look at the right-hand side, we've got a diagram of circular motion. The velocity vector, so v with the arrow over it, is always a tangent. The force, the centripetal force, and the linear velocity are always perpendicular. These are things to remember. The radius vector is away from the center at all times, so it's along the same path of the centripetal force but the opposite direction. And then both the centripetal force and the centripetal acceleration are directed towards the center, which means they're in the same direction. Now the last bullet point there, I've got N1, that's Newton's first law, says if there's no net force acting on a body, the body travels at constant velocity, so there's no acceleration. Just F is equal to ma there should explain that for you. No F, no A. If A is 0, moves at constant velocity. So if we look then on the left-hand side at question 1, the direction of the linear velocity is always a tangent to the curved path. Okay, with question 2, if the gravitational force disappears, Newton's first law says there's no force, there's no acceleration, and if there's no acceleration, it'll keep moving at constant velocity. And we know that for a circular path, if you took away the force and the velocity is a tangent to the circular path, then the particle would travel along the tangent to the path at that point. So it would continue to move with the velocity along tangentially to the original orbit. So B is the correct answer. All right, let's have a look at the right-hand side at the bottom. What are constants and what are changing? So the velocity vector, the force vector, and the acceleration vector are all changing direction. So they're all changing. The magnitude of them aren't changing, however, so they're constant. So the linear speed is constant. The magnitude or the size of the centripetal acceleration and centripetal force aren't changing, so they're constant. And likewise, the angular velocity, we're assuming it's unchanged here. So there's no angular acceleration. It's rotating at the same rate. So question 9 then, which of the following quantities are constant? It was the linear speed and the angular velocity. Right, 3. Some calculations. We have 0.5 radians and we have 20 rads. You can pause the video to check that out if you didn't get them. 4. Okay, if a particle moves in a circular path with angular velocity, which is changing in magnitude, then it has to have an angular acceleration. It's speeding up or slowing down. So the answer there, look, it does have an angular acceleration. The angular acceleration is only rotational, but because it's got a centripetal acceleration that's changing, it should also have a tangential or linear acceleration that's also changing. So that's C, I believe, there. And then the last one, I had a look at this already, a half mv squared, but v is equal to rw, and that would give you the answer I showed you previously. And then P is the momentum, mass by velocity, and I showed you that previously as well.